Okay, now let us start with the first question over here, and first we are discussing the questions of production, okay, workshop technology as well as manufacturing technology. So first let us discuss that questions what we are having. So first question is, dash is used to scribing two parallel lines at a time on a wooden work surface. Options we are having it as marking gauge, mortise gauge, bevel gauge, feeler gauge. Okay, so whenever we are discussing this part over here, now what will happen means many times we are using the tools. What are the tools we are using in carpentry? Because what is given over here, it is given that wooden work surface is given. What is given? Wooden work surface is given. If wooden work surface is given, what we have to take over here, we have to take all the carpentry tools. So in carpentry tools we are having number of measuring tools we are having, marking tools we are having, striking tools we are having, boring tools we are having. Okay, all this number of then similarly planning tools also we are having. All these tools, if you remember only the listing of that part, you can give the very easiest answer over here. So what are the measuring tools we are having? Measuring tools means we are taking it as normal steel rule we are taking, wooden scale we are taking, or else wooden folding rule we are taking, or else steel tape we are taking. All this will be coming under what? Measuring tools. Similarly boring tools we are having. Boring tools like gimlet, auger, or else bradole, all this will be braces, all this will be coming under what? Boring tools. Okay, planing tools we are having. Planing tools means jack planes we are having, metal jack plane, wooden jack plane, like that we are having. Similarly in the case of marking tools also, what we are having? Straight edge, tri-square, bevel square, combination square, marking gauge, mortise gauge, divider, trammel, all this we are having coming under what? Marking gauges. Okay, so similarly marking tools whatever we are taking, marking gauge means we will be having only one pin. Suppose this is a marking gauge we are having only one pin over here. If you are having only one pin means we can mark only one line. Now what will happen over here? What are the options? Marking gauge, bevel gauge, feeler gauge, mortise gauge. If you are going with the mortise gauge over here, for mortise gauge we are having the two pins. What we are having? We are having the two pins over here. With the help of two pins, what we can do means we can mark the two lines. We can mark the two parallel lines at a time simultaneously. So that's why what is asking over here, dash is used to scribing two parallel lines at a time on a wooden work surface means which option will be correct? Third option is correct. Mortise gauge we have to remember. That's it. Okay. Now let us go with the next question over here. What is the name of the chisel used to chip off excess metal of welded joints and castings? Now what are the options given over here? We are having the options as cross cut chisel, flat chisel, diamond point chisel, and next we are having it as half round nose chisel. Okay, if you are going with this concept over here. So if you are going with cross cut chisel, it is actually used for cutting grooves, or else slots, or else keyways. So this we are using, cross cut chisel we are using for these cases. Okay, now next diamond point chisel we are having. If you are going with a diamond point chisel, if you want to do the squaring of the corners, what we are doing over here? Squaring of the corners. Okay, squaring at the corners we can write over here. This part we have taken. Now next part what we are having? Flat chisel we are having. Okay, flat chisel and a half round. Half round it is actually used for curved grooves. It is used for what? Curved grooves we have taken. And now flat chisel we are having over here. What is the meaning of flat chisel? The chisel which is used to chip off excess metal. If you want to remove some excess metal from the workpiece, then which chisel we are using over here? Flat chisel. So option 3 is correct. Now let us go with the next question over here. Which of the following process belongs to forging operation? Now we are having number of forging operations actually. First operation we are starting with upsetting. We are starting with what? Upsetting. Then we are having it as suppose if you are taking it as drawing down. Okay, drawing down operation also we are calling that part upsetting. Drawing down we have taken. Then similarly flattering we are having, fullering we are having. All these operations will be coming under what? Forging. So let us see this part what we are having. Fullering, welding, piercing, drawing. Drawing if you are taking somewhat a sheet metal operation means that will be different. Piercing is also that sheet metal operation. Welding is different. So what is forging operation we are having over here? Fullering. Okay, fullering it is actually related to drawing down operation. Setting down, or else we can call it as what? Setting down. What is the meaning of upsetting we are having? Upsetting. What is the meaning of upsetting? Means whenever we want to increase the cross sectional area, if you want to increase the cross sectional area and there will be reduction in the length, then we are calling it as what? Upsetting. Similarly, what is the meaning of drawing down or setting down? Means if you want to increase the length of the workpiece and we want to reduce the cross sectional area, then we are calling it as what? Drawing down. So this drawing down operation, operation, it is very much similar to what? Fullering over here. Fullering, it is also called as what? Necking down operation, and it is related to what? Drawing down. So that's why we are taking this part as what? Option 1. Fullering is, we are having it as what? A forging operation. Now next, the following one is applied to improve the surface finish of the casting. Which sand we are using if you want surface finish of the casting? So we have taken facing sand, sawdust, coal dust, iron oxide. So these options are somewhat different over here. Actually, if you want the surface finish, means we want silica sand. What we want? We want silica sand and amount of clay also. So whenever we are having the composition of silica sand and clay, then we are getting the better smoothness and surface finishes of the casting. So which sand is having that composition? Means facing sand. Facing sand, it is having what? Silica, composition of silica sand, and what we are having over here, we are having it as clay. That's why we are calling this part as what? Facing sand will give what? Surface finish of the casting. Now the purpose of metallic chills used in casting is to progressive solidification, avoid all the defects, increase in strength of the casting, directional solidification. Now what will happen actually, whenever we are performing the casting operation, we are having the mold cavity. After preparing the mold cavity, we have to pour the molten metal. Whenever we are pouring the molten metal, now it should solidify. If it is taking more time for solidification, we will be having somewhat defects over there. Again, it is taking more time like that, it will become disadvantageous. So what we are doing, we are taking some object over here. Which object we are taking? Metallic object. What we are taking? Metallic object, we are calling it as chills. Now what is the purpose of that metallic object? Chills means whenever we are pouring the molten metal, after the pouring of the molten metal, the solidification will be very quickly. Solidification will be done very quickly. So for that sake, we are using the metallic object chills over here. So what is the function we are having? The purpose of the metallic chills used in casting is to what? Directional solidification. For directing that solidification, we are having the chills over here. So option 4 is correct. Now next question, investment casting is also called as, this is very simple and direct question we are having. Investment casting, it is actually coming under what? Expendable method. Okay, in expendable method, what will happen in the expendable method means after the solidification, we will destroy that pattern what we are having. Okay, pattern what will be there now, mold cavity what we are having, that will we are damaging and we are destroying and we are taking out the final product. Okay, so in this case also it is related to expendable casting over here. Whatever the pattern we are using, the pattern will be made up of what? Wax. It is made up of wax. So that's why what will happen after completion of the cooling part, after solidification, we are melting that wax. Whenever we are melting that wax will be melted, it will be gone outside and we are getting the what? Final product. So that's why what we are calling over here investment casting, as the pattern is made up of wax and wax is melted over there, that's why we are calling it as what? A lost wax method. What we are calling? Lost wax method. Option 3 is correct. Now next question, dash pattern is used when the contour of the part is such that withdrawing the pattern from the mold is not possible. Now what will happen sometimes, suppose this is a mold cavity we are having. Suppose this is a mold cavity. Okay, this is a mold cavity we are having over here. Or else let us take this part. Let us take this part as a mold cavity we are having. Okay, now if you are placing like this rectangular piece, rectangular pattern we have taken means it will be removed very easily. It will be removed very easily. But sometimes what will happen, if you are having like this, if you are having some shapes like this, conical shapes we are having like this at the corners, so it will become very difficult for taking out that pattern. Okay, if you are having the solid pattern, means it will become very difficult. So for the difficult shapes, what we are doing means we are providing these pieces. This will be one piece, 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 like that pieces we are providing over there. Okay, so whenever we are providing that pieces, we can take out that pattern very easily. What we can do? We can take out. Let us take some example over here. Suppose if you are taking like this. Suppose like this pattern you have taken. So if you are taking this pattern, okay, this is a pattern you are having. This is a pattern you are having. And this is a shape also we are having. So if you want to take out this pattern, means this part will be destroyed or damaged. Okay, this part, if you want to remove this pattern like this part will be destroyed or damaged. So what we are doing over here means, listen here carefully what we are doing. So we are providing this piece separate, okay. So first what we will do, we will remove this pattern. After removing this pattern, the small pieces what we are having, the small pieces we can remove slightly over here, that small pieces we can remove, okay. So that's why dash pattern is used when the contour of the part is such that withdrawal of the pattern from the mold is not possible. Means which patterns we are using over here? We are using the loose piece pattern. We are calling that type of patterns what we are calling over here, loose piece patterns, because first we are taking this pattern, this complete pattern, it is not fixed with the small piece over here. So that's why this pattern we can remove very easily. Then we are taking out these small pieces. That's why we are calling it as what? A loose piece pattern. When we are using that loose piece pattern, means whenever that withdrawal of the pattern will become very difficult, then in that cases we are using that loose piece pattern. So option 2 is correct. Now next question. In a broaching tool, the teeth which are responsible for the heaviest cutting is. Now suppose if you are taking this tool over here, broaching tool, if you are taking over here, simple diagram I will draw over here. So if you are taking these teeth, what we are taking these teeth over here. If you are taking these teeth, broach tool we are taking. If you are taking this broach tool we have taken, means starting we are having it as a rough teeth, then we are having it as a semi-finished teeth, then at last we are having it as last one or two will be what? The finished teeth. Okay, so all together we are having at one tool itself. Whenever we are taking the broach tool, means in one tool only we will be having the rough teeth, we will be having semi-finishing teeth, and we will be having what? Finishing teeth. All that operation will be performed simultaneously at that one time itself. Okay, so now what is happening over here? In broaching tool, the teeth which are responsible for heaviest cutting means which teeth we can take over here? Rough teeth. With the help of rough teeth, more amount of material, means heaviest cutting operations we are performing. Then if you want to give some surface finish, some finishing or finishing part if you want to give on the workpiece, means then we are going with semi-finished teeth and finished teeth. Okay, so which option will be correct over here? Rough teeth. Option number 1 is correct. Now metal removal rate of the shaper with a cutting speed of 40 meter per minute, feed rate we are having it as 0.5 mm per stroke, and depth of cut 5 mm we are having very simple formula over here. Whenever cutting speed, feed and depth of cut is given, we have to multiply all that for finding out the metal removal rate over here. So 40 meter is given. Meter means first we have to write in the mm. Mm means what we are writing? 40,000. 40,000 we have taken into 0.5 into 5. Okay, if you are multiplying this, we will be getting the answer directly over here. So which option will be correct now? Ones, tens, 100,000, 10,000 lakh. Okay, so this part, second option is correct. And we are having the units as what? Mm cube per minute. Okay, so only that numbers what we are having, that numbers we have to multiply, but this meter we have to convert into mm, then we have to multiply that values and we will be getting the answer. Okay, now, so this part we have taken. Now next question. In a slotting machine, the part which houses complete driving mechanism is. Now where we are having the complete driving mechanism, actually we will be having this slotting machine like this. This will be the base part we are having, this is a column part we are having. Okay, then we will be having some tool mechanism over here. So all this driving mechanism what we are having will be there in what? A column. Where we are having all this driving mechanism in the column itself. Okay, like milling machine will be there, in the milling machine also all that whatever the driving mechanism we are having, it is in the column itself. So over here also in the slotting machine we are having all the driving mechanism in the water column. Option 3 is correct. Now next part, which driving mechanism of planing machine do not have speed reduction gearboxes? So driving mechanism is all we are taking it as driving mechanism only, but in which mechanism of the planing machine we are not having the speed reduction gearboxes, means we are going with the hydraulic drive. Okay, hydraulic drive we are not having the speed reduction gearbox. Now which one of the following is not a desirable property of a cutting fluid? Whenever we are going with the properties of the cutting fluids, what will happen means we are having some properties over here that it shouldn't cause skin irritation. It shouldn't cause skin irritation, and smell, odor should be not there. Whatever the bad smell what we are having, it should be not there. Then next we are taking it as transparent. It should be water transparent, and it should be what? It should not cause fire. It should not cause any fire. Okay. Then similarly, the whatever the cutting fluid we are using, it should be of good lubricating property. Good lubricating properties. Okay. Next, it should be of high heat absorption capacity. High heat absorption capacity. Now next, high flash point should be there. What should be there? High flash point. So all these are more also we are having, but important we have written over here. This all will be coming under what? Properties. So let us check the options. And what's the question? Which one of the following is not a desirable property? Not a desirable property means good lubrication we are having, high heat absorption capacity we are having, low flash point. But we are having what? High flash point should be there according to the property of the cutting fluid. But what is given? Low flash point is given. So preventing addition of the metal and the tool point means this is also correct. But third option is wrong. Third option is wrong means we should have high flash point, but it is giving low flash point. So it is asking not means low flash point. Third option is correct. A welding process in which a heavy electric current is passed through the metals to be joined over a limited area, causing them to be locally heated to plastic state, and the weld is completed by application of pressure for a prescribed time is. Okay. Now which welding we are calling? Listen carefully. Suppose we are taking the two pieces over here. Two pieces we have taken. This is one piece and this is one piece we have taken. Now over here we are having the electrode and we are having setup over here. Okay. Electrodes we are having, and we will be having positive terminal, negative terminal, DC source we are having. Okay. Positive terminal, negative terminal, DC supply we are giving over here. Now whenever that current is passing, what will happen? We are due to that electric current what is passing over here, we are getting the spot over here. What we are getting? Spot. With the application of the pressure we are getting the welding over there. So that type of weldings, whatever the definition is written over here now, all the definition, it is the meaning of what? Resistance welding. What is the meaning of that part? Resistance welding. We can take some examples of resistance welding means this example what we are having, spot welding we can take. Then similarly seam welding we can take. Then next we can take it as projected welding, projection welding like this. All these weldings will be coming under what? Resistance welding only. What is the meaning of resistance welding? Electric current is passed through the metals. Whenever the electric current is passing and we are applying the pressure, so heating, it will be heated. Whenever the electric current is passing over here means it will be heated. After heating at this region, we are applying the pressure. So whenever we are applying the pressure for the prescribed time, we will be having the joint over there. Okay, whenever we are having the joint, that type of weldings we are calling it as what? Resistance welding. What are the examples? We can take spot welding, seam welding, projection welding, like that, all the examples we are having. Now let us see the next question. The ingredient of electrode used in welding which provides a reducing gas shield and increases arc voltage is. Now what is the ingredient we are taking of the electrode that it is providing the gas shield over here? Gas shield means we can take it as CO2 and H2 gases we are taking over here, and actually whenever it is increasing the arc, it is used for deep parts over there, for the depth, for deep arcs we are using this ingredient. What is that ingredient name? Means we are calling this part as cellulose. We are calling this part as what? Cellulose of the electrode which is providing what? A gas shield, and it is increasing the what? Arc voltage. Okay, so option 2 is correct. Now next, in a fluted milling cutter, inclined angle between land and face of the tooth is called. Now if you are taking the milling cutter over here, what will happen? Milling cutter if you are taking means, suppose this part we have taken. Like this we are taking over here. Okay. Now in this what we are doing means, this part we are calling it as a land. This part what we are calling land. Now we have taken some tangent over here like this. Okay. Now for this tangent and for this line if you are taking over here, this part we are calling it as relief angle. What we are calling? Relief angle. We are calling this part as relief angle. Now next part what we are taking means, next part, let us see here very clearly. Just a minute. Okay, so what we are doing for this part means, over here we have taken okay, like this we have taken, again we are having like this, cutter will be there, milling cutter will be there. So this part we are calling it as what, a land. Okay, this is a tangent we have taken, and this line what we are having, the starting line we are taking it as relief angle. What we are taking, this is relief angle we have taken. Now this line what we are having, this line we are taking this part as a primary clearance. What we are taking, primary clearance. Okay, now next this line what we are having over here, this part we are taking it as what, a secondary clearance. Okay, three lines we are having over here. First line we have taken it as relief angle, second line we have taken it as primary clearance angle, and third line we have taken it as what, a secondary clearance angle. Okay, now in this part also, if you are taking this, if you are taking this concept, now over here from the land to the face, this is a face we are having, this is a face we have taken, and this is a land part we have taken. What is the angle between this land and the face means we are calling it as a lip angle. What we are calling this angle, we are calling it as what, a lip angle. And this angle what we are having, this angle, this is the axis we have taken, this angle we are calling it as a radial rake angle. Radial rake angle. Okay, so these angles we have discussed over here. So what is asking actually, in a fluted milling cutter, inclined angle between land and face of the tooth is called what we are calling, lip angle. Fourth option is correct. Okay, lip angle is correct. Now next, a milling operation which involves use of combination of more than two cutters mounted on the common arbor. Now it is very simple. Whenever we are using combination of more than two cutters, if you are using more than two cutters and we are performing the operation, then we are calling that part as what, a gang milling. What we are calling that operation as, gang milling. Now next, the term which indicates a spacing between abrasive grains on grinding wheel is grit, grade, structure, grain. Now what is the meaning of grit means? It is related to grain size. It is related to what? Grain size. Now what is the meaning of grade means? Whatever the bonding will be there, now whatever the bonding between that abrasive grains and the wheel, whatever the wheel we are having and abrasive grains we are having, and between that abrasive grains also, one abrasive grain, another abrasive grain, what is the bonding we are having? That the bonding we are having with what? Grade. Now structure it is related to spacing of the grains. Structure it is related to what? Spacing between the grains. So what is asking over here? The term which indicates spacing between the abrasive grains on the grinding wheel means option 3 is correct. Okay, option 3 is correct. Now next, the surface finishing operation which is performed after polishing to provide a high luster to the polished surface is. Now let us see this part. Lapping we are having, horning, super finishing, and buffing we are having over here. Lapping means it is also a finishing operation. It is also a finishing operation, finishing the flat surfaces. Whenever we are having the flat surfaces, for finishing that flat surfaces we are calling that part as what? Lapping. Horning means, horn we are using a tool, we are calling it as a horn tool, and it is used for finishing the drilled hole. Whatever the drilled hole will be there now, for finishing, for smoothing that drilled hole, we are calling a tool as horn tool. With the help of horn tool we are finishing the drilled holes. Okay, horning we are calling. Now super finishing also it is similar to that lapping only, but over here we are finishing cylindrical workpieces. Okay, cylindrical. Suppose this cylindrical workpieces we are taking over here. Cylindrical workpieces we are taking, and this is a tool we have taken over here. With the help of this will be reciprocating, this will be rotating clockwise, and we are applying the pressure over here. So this part, whenever this tool it is moving like this, reciprocating like this, this is also rotating, so we will be getting the finishing on that cylindrical workpieces. Now buffing means what? It is very much similar to the polishing operations. It is very much similar to what? Polishing operations, and we are using very fine grains over here. Whenever we are using very fine grains and is related to polishing, what is the question we are having? The surface finish operation which is performed after polishing to provide a high luster. After polishing also, if you are using very fine grains means, then we are calling it as what? Buffing. Okay, option 4 is correct. Now next part, the operation through which a metal is cut along a single line, usually a straight line, is what are the options? Shearing, parting, notching, trimming. Trimming is somewhat different. If you are removing some extra material over there, that we are calling it as a trimming. Notching, what we are having, if we are cutting the edges of the workpieces, then we are calling it as a notching. Then parting, what we are having means, suppose this part we have taken, if you are having this shape, if you are having this shapes over here, and if you want to remove only this parts, only this particular part, and this remaining part will be scrap, so that will be coming under what? Parting. Now if you want to do only the single line process, single line straight line cuttings we have to do, means we can go with what? Shearing. First option is correct. Now the locators which are used to locate the work from an external profile or outside edge are. Locators, what is the use of the locators? Means it is used for locating the work pieces in the jigs and fixtures. Jigs and fixtures will be there now. So what is the use of that locators? Means for locating the work pieces where we are having the position in the jigs and fixtures. Okay. So in the name, in the question itself it is given, it is used to locate work from an external profile. Profile means which locators we are using over here? Profile locators. Okay. Option 2 is correct.